Hey guys, what's up? In this video, I'm going to show you BFS, that's breadth first search, and unlike the other videos where I write the code on the fly as a record, but in this video, I'm not going to do that. I have written this code before and I'm going to explain every bit of it because what I have seen is the videos get really long if I try to write the code, and so I'm just going to give it a try here, where I'm going to explain the code which I have written beforehand, and let's see how this video goes. If this video gets more likes or more support than the other videos, then I'm going to continue with this scheme where I explain the code which I have written and I don't write the code on the fly. Anyways, um so this is the adjacency matrix which I made, and if I can show you the graph from which I made the adjacency matrix, it would be very cool actually. So let's go to YouTube and let's just write BFS, and this is the graph which I took for my example. Oh my god, there's an advertisement here. Okay, this is okay, we skipped it, and as you can see, this is not my video, as you can understand, someone else's, but this is a very fine video and the theory here is superb. It is awesome. I referred to this theory myself and I suggest you guys to go through this theory as well. It's perfect, and but this example I'm going to take here, this particular graph I'm going to take here, and I created the adjacency matrix of this graph, and only difference is here A, B, C, D, like this it is given, and I replace the names like A is 1, B is 2, C is 3, like that, because come on, it's more easier that way, right? Okay, now let's go to main method first. When you go to main method, okay, I write these lines nq1, nq8, nq9, dq, because like in a breadth first search you use a queue, and in a depth first search you use stack, like so it's a queue, so I will test the queue operation. So nq1, nq8, I'm doing all this to nq data in the queue, and then I call a dq function, remove a data, and then I view the queue. This I do so that I can test my queue is working or not. This is the only objective of this. You really don't need this in a hardcore breadth first search algorithm. Anyways, then I call the default values function. What does this function do? The default value function, it assigns default value to our arrays. Now the breadth first search algorithm, if you know the theory, you would know that we at one, okay, let's go to the BFS function. Now it will be easier for me to explain this way. So this is a BFS function, it accepts a particular row, then there is three variables, int I, val, and count. Count is, I think it's count is for count, because I've written this code 3 days back and I don't really exactly remember, but I will make it less awkward for me and for you. So anyways, so let's, for the time being, let's say it's count. So count is equal to 0. Now for I equal to 0 up to 9, I plus plus. Why 9? Because of this array. This there are 9 elements from, that's why it's from, it's there is the loop is up to 9, from 0 to less than 9. Then if AR of row and I means the equal to 1, what this is doing, it is finding if there is a edge from our particular edge to some other node. If there is an edge from A to B, it is searching that, like for every other node it's testing, like a to b, a to c, a to d, a to e. Is there an edge from a to e? No, that's why it will be 0. A to e will be 0, a to b is 1, a to d is 0. So I mean, like if you're using adjacency matrix, this you should be knowing, right? So this is what it does. It checks all these, and it checks this. If it is 1 means if there is a adjacent node to our currently working node, then it checks if it is visited or not. If is visited of I means the node which we are checking, like our currently working node is a, then we are checking b. If there is an edge between a and b, then this part is getting true. Then we are checking if is visited of I is equal to 0, means it is checking is b previously visited or not. If b is not visited, 0 is means I have written this is visited function, and if is visited of I is equal to 0 means if it is not visited. If it is not visited, then enqueue this particular node and then add this particular node to the visited list. Okay, so we have an array here, visited. This array will hold or store the nodes which are already visited. This is our output of PFS, right? And this is the add visited function. It's very easy. Visited of ptr plus plus is equal to data. What is ptr? Ptr is a pointer which stores the address of the visited, like it stores the address, like where to add the new entry in the visited array. Like this is visited array, and ptr is initially 0, so visited of ptr plus plus means at the 0th position add some data, then ptr is incremented by 1, so ptr now is 1. Then next time some node will be inserted in the visited array, the add visited will be called add visited. Will the visited thus 1th position means the second position of the visited array would be populated by this data. Pretty easy. Then this is the function is visited. Now what does is visited mean? Is visited, as the name suggests, it will check if a particular row is visited. If the row is already visited, it will return 1, means the row is already visited. If the row is not visited, if the row means I mean a node, if the node is not visited, then return 0. So if node visited, return 1. If node not visited, return 0. How to check that? We'll run a for loop from 0 to 9 I plus plus. If visited of I is equal to data, means if there is an entry in the visited matrix of this particular node, then it is already visited, right? So it return 1. If this entire thing is false, then it will return 0. It's very simple, nothing fancy here. This is it, guys. I mean, like literally this is it. Okay, so what is the idea? A is a currently working node. We will check the adjacency. We will check the adjacent nodes to our currently working node. Like from A, we'll check all the nodes and to which have an edge, like which are the really the adjacent nodes. We will enqueue them. So we first enqueue B and then we'll enqueue S, right? This is what is happening. If not visited, then enqueue V, enqueue S. Like it's going in a loop, right? So first B will be enqueued, then S will be enqueued, then we will dequeue the topmost element. We'll dequeue the topmost, we will dequeue the topmost element will be dequeued as this is the property of the queue, right? You should be knowing queue. So this is the property of the queue. We will call dequeue and the topmost element will be dequeued. If val is not equal to -1, means if the queue is not empty, then we will call bfs function on the topmost element. That's it, guys. This is it. This is the function. Then else means if the queue is empty. If the queue is not empty, we will do this work. If the queue is empty means val equal to -1, then our work is done. So we'll just view the elements. So we are calling the view visited. Now what does view visited function do? View visited function just loops through the entire visited array and then uh, print and then prints each of the element. That's it, guys. I mean, this is the output, obviously, right? Just run this function once, and if you, as you can see, we'll be seeing. Okay, now you can see this is the output which I am getting, and if we run this bit to the end, we can see the same output which they are getting as well. So in this way I can verify, I verify that my output is correct. Well, it's given A, B, S, C, G, D, E, F, H, and mine is coming 0, 1, 8, 2 like this. So how is it correct? Well, I said before at the starting of this video, A means 0, B means 1, 8 means S, because come on, like let's go to C first. C means 0, 1, 2, right? A is 0, B is 1, C is 2, so it's 2 here. Then D is 3, E is 4, F is 5, G is 6. So this is G and 6 is here. Then like this, right? And then D means 3, 0, 1, 2, 3. So in this way you can see that my output is coming correct, and then in this way I verified this algorithm, and this algorithm will work for any type of array, uh, regardless of this particular graph or not. This algorithm will work for any graph, not only for this graph. We just have to change this, like hard coded here 9, right? You have to change this and you change the graph. This is it. It's pretty easy actually. So before ending this video, I will just go through the key points one more time. So void BFS int row means it will accept a particular node. Then why I'm saying row here, because in this adjacency graph, adjacency matrix, this is row 0, this is row 1, this is row 2, row 3, row 4, row 5, like this. So I'm writing here row, but I mean the node. Then I will check all the nodes. And if there is an adjacent node, this code will check if there's an adjacent node or not. So if there is an adjacent node, I will check if it is visited or not. If it is visited, we will not bother with it. If it is not visited, is visited is 0. So if it is not visited, I will enqueue that row, and then I will add this row, I will add this element, I will add this node to the visited list. That's it. This is the job of this code. So after executing this code, all the adjacent nodes to the currently working node are enqueued in the queue. Then I will call the requeue function and store the result in val. If val is not equal to -1, means if the queue is not empty, then I will call the BFS function on val, means the topmost element of the queue. I will call BFS on that. So val is our new currently working node. Now else means if the queue is empty, then we will try to view the visited matrix, means will be the output is stored in the visited matrix. So this is a BFS algorithm, guys. It's pretty easy. It's nothing very difficult. That's it, guys. This is all for this video. If you like it, do hit the thumbs up and keep coding. Take care.